thanks for coming, everyone that came here. So, welcome to creating products with Upstream software. My name is Andre Aldea from Texas Instruments. I do community development, and the best way I can describe my job is I'm basically the Lorax at TI, so I care for the trees. We're here with some of our partners to talk about how you take a product from silicon all the way to an actual product that you sell with Upstream open source software, or if you even can. We just kind of discuss through it. So if everybody wants to introduce themselves, we'll start with Stefan. You don't know, do you? Okay. Yeah.
Hi. Okay. Yeah, my name is Stefan Müller-Glieser. I'm from FiTech. I'm a physicist, but at FiTech I started as a software engineer working on the AM335. So this was my first software development professionally. And now I'm the head of the software development.
Okay.
Yep. Hi, John Oster, Toradex. I'm probably the person here who's usually spends time farthest away from Silicon. My background, my job is product security. My background is in designing secure software update systems in automotive and safety critical environments. And now I do that kind of security work for Toradex with a strong focus on the CRA and emerging cybersecurity regulation.
Thomas Pelazzoni, Bootlin. We help our customers put Linux on their hardware by providing engineering and training services around embedded Linux, and that involves both doing initial Linux bring-up, but also maintenance over the long term.
Hi, I'm Kevin Hillman with Bay Libra. I'm also part of an embedded consultancy, software consultancy, and we help companies like TI and other silicon vendors also on their various embedded software products. And we're not making products ourselves, but we're helping people make products with TI chips as well as others. So.
Hey, hi, this is Vishnu here from Texas Instruments. So my primary background is from the Linux BSP and bootloader development. Here in the TI, basically I work on enabling the different verticals on the Linux, such as like, Pro Audio or Analytics or basically, any new segments which can help the customers, right? So that's what I do.
I'm Jason Kreidner with BeagleBoard.org. Try to find ways to demystify computer technology for folks and train them to become embedded Linux developers and ultimately turn computers into things that do what you want them to do rather than what somebody else wants them to do.
Hi, I'm Neha, and I work with Texas Instruments mainly on the U-Boot development side. And I work on DDR and UFS IPs. And I've been with TI for the last 3 years. So, yeah.
All right. So this presentation was billed as a fireside chat, so I think we should get cozy. Okay. And now we can talk about we'll start with a scary topic. So everyone right now in Europe is worried about CRA compliance, and I think that's going to drive a lot of how industry behaves for the next couple of years. So I think we can start with John explaining why.
Yeah, I'll talk about this a little bit. You can find me talking about the CRA in detail in various places online, and I would take up the whole time if I went into detail on everything. But this is a really important topic, not just for anybody who is a European company creating products, but anybody who wants to sell products in Europe. The CRA binds you. If you want to sell your product in Europe, you need to come into compliance with it. And it comes with some, I think, very reasonable requirements if you have a kind of a modern development process, like requiring software updates, various requirements around vulnerability handling. But it also comes with a big stick. So one of the things in the CRA is that you can get fined up to 2.5% of your global annual revenue for a violation. It's one of these big, nasty EU. Oh, yeah. One of these big, nasty EU regulations that kind of has a lot of potential. It's similar to GDPR, but for actual products. And one of the things I wanted to talk about here in this chat is upstream first policies and mainline Linux, especially how that really interacts with the CRA and helps with the CRA. So maybe I'll just start by laying out why, and we can jump off from there. You have vulnerability handling requirements under the CRA. If you know about an actively exploited vulnerability in your product, you have 24 hours to report it to the regulator. You have 72 hours to get a detailed report to the regulator, and you have 30 days to get them a post-mortem root cause analysis detailed report. It's harsh, and you've got to deal with it. You've got to actually mitigate the issue. There are also other things around vulnerability handling. When you first place the product on the market, it can't go on the market with known exploitable vulnerabilities, and so all of these things require regular software updates in general, or some ridiculously defined down threat model and strong perimeter if you want to play it like that. But really what you need to do is ship recent software and continually update it. And that's something that's really hard to do in kind of this traditional embedded model that I think a lot of us are aware of. You get some vendor kernel that might be a few years old, and you get a golden image, and then you just never update your device for 10 years. You don't even build a software updater into it. You literally can't do that anymore. Hopefully nobody in this room is doing that. Show of hands. Okay.
So since I deal with a lot of very newbie folks that maybe like dictionary passwords, because that really makes development a lot easier when you can give somebody the instructions to log in instead of the first time you come up to your dev board and it's asking you to change the password, or somehow you've had to figure out some way to set some private password. But I would put out a challenge to folks, right? Even something as simple as SSL, right, for web browser, right? So right now for developing with our boards, the first thing you have to do is point your browser to it and tell you trust its own certificate that is self-signed in order to get access. And that's like not so happy an experience for somebody that doesn't know why they should trust something that they don't actually trust.
Everyone wants to expose their home lab nowadays, right? Like, oh, I have a home lab at home now. I want to expose it to the internet, and then no SSL.
Yeah, so I mean, I think we want to make things developer friendly and easy to get going, but trying to teach somebody new to how to deal with the situation they don't know anything about, and you're asking them to do it first and foremost. How does somebody get to trust their own devices? Anybody on the panel? Like, why would you trust somebody's software that in order to begin your development?
I'll start with that. So first of all, I think the position of Beagle or somebody like Toradex, when you are shipping a raw board to people who are intended to use it for development, your obligations, like our obligations, are a bit different from the obligations of the people who are making the product. So this is maybe getting into debatable lawyer territory, but in general, we're shipping developer tools, and the intended usage of those tools is, hey, we're going to ship you a board that you can put whatever software you want on and build a product with it. And so the security model for that is a bit easier to fulfill. It's a feature, not a bug, that you can flash random software on. If you have an end product that is for example, something that might be part of civil infrastructure or be available in public, under the CRA, you're going to have strong secure boot protections. You're going to have to meet a much more difficult and restrictive security model. And it's up to you, the manufacturer, to make sure that you build that chain of trust into your products. And I think what we can do as suppliers is do our best to make that easy. I mean, Toradex, we have, and this is what my team works on, the MetaToradex security layer to try and make implementing secure boot and various other security features like partition encryption backed by excellent hardware security in, for example, TI's chips that we use, make that easy to use and put into a product. But it wouldn't make sense for us to enable secure boot images signed by Toradex keys out of the box. I mean, so you have to
what we have to do is communicate to our customers, the people making products, how to do that.
Right, I agree with on this, right? Basically, when a customer goes, okay, I want to have this board or that board, right? How they will trust your hardware, right? So then it comes, I agree, the secure board is the one thing. And then whether your software is part of the CIP, civil infrastructure project or not, right? Because that gives them a confidence that, okay, the vulnerability in the system will be handled and the updates will be available. Also, this your CIP provides the updates, regular updates. That is mandatory over there, right? So when these things are coming and your software is basically certified for CIP, right? Then definitely it gives an edge to know, yes, this device is okay to use it for their products.
And how does an individual do that on their own desktop, right? So how do they know that they can trust that software?
So individual, right? Again, when they are developing the software for that, right? So again, it's come the secure boot, right? Whether that whatever the software they are developing, whether someone can breach that software or not, right? That's the one point over here.
I mean, you're talking more about sort of trusting trust. How can our users trust that the tooling, the initial images, everything that comes from TI or Tortex or so on actually works? This is my jam. So software supply chain security obviously is really important for everything from developer tools, but there exist good open standards out there to provide strong attestations for this stuff. And if you implement that, you will enable your customers to do it. So for example, our binary distribution images, we produce in our CI, we produce in toto attestations for all of our builds. So if you want to, you don't have to just trust that the binary you download comes from the right place. You can look at the in toto attestations, verify the signature on those attestations, and know exactly what the hash is of every single file that went into that Yocto build. And that's available publicly. You link that up to a standard like TUF or Uptane so that the software artifacts you build go into a signed repository that represents the valid software state of your product or the valid set of software that can potentially be installed on the product. And then you use an update client that does good best practices security, which, by the way, I have a bone to pick with the civil infrastructure project on that piece. I'm not a huge fan of SW Update's security model. You use something that implements best practices there to keep that whole chain secure. So it's this combination of open standards and technologies, and in toto, TUF, Uptane, all Linux Foundation, CNCF, or JDF based projects. They're not, some proprietary standard. You can implement them yourself, source. Of course, you're welcome to use the Tortex implementations of them, but you do all of that stuff following the standards. You follow the what's out there in the open rather than trying to roll it yourself.
So just wanted to maybe refocus a bit the discussion on Upstream because we've kind of lost
That's a very
track.
good point.
Yeah, right. And so I think at least at Berlin, and I guess it's same for you, we've always recommended our customers to use Upstream-based kernel, Yocto, and other open source components initially for having higher quality because the code has gone through the review process of the community to help with reducing the maintenance cost because even without CRA, it's very common that you want to upgrade to get new features and bug fixes and so on. But now with the CRA, it has become not like a nice to have, but like
Absolutely
a
mandatory.
must have, right? So it means that when you design a product, choosing the right hardware and the right software that has this upstream support is becoming even more key than it has ever been in the past. So it's good to see silicon vendors who are embracing that and have that policy of pushing support upstream because ultimately that's what companies building product will need because otherwise, without upstream support, especially for the kernel, which is really a highly complicated piece of software and highly security sensitive compared to even other parts of the system, if you have a downstream kernel with hundreds of thousands or millions of lines of patches on top of mainline, you're screwed basically. So.
And I think this actually fits into our next topic perfectly that I was going to bring up. So, we all say, okay, the upstream kernel, let's keep using that. But at the end of the day, what do customers actually use? Do customers ever go to production with the upstream kernel? And, what about features that are enabled not in the upstream kernel that are on a recent kernel, but they're a vendor kernel? And, pros and cons, what are the challenges there? Why not just always use upstream? Or why don't they use upstream? I guess that's the question, right? Like, why wouldn't they if it's so great?
Okay, yeah. So, in this panel, I guess everyone agrees that upstream is the way to go, and the
Same
solution.
for the record.
Yeah. So, this is not easy to start in discussion, but I will try at least to say that, upstream is the way to go, but you always have to consider the time frame of your product. And to coordinate a lot of people, it's a huge effort, and it takes a lot of time, a lot of communication. And so not from day one, you can be upstream. So only Linus, with his initial commit, with his initial Intel support, he was the only one directly upstream. Yeah, but all the others, we have to think about how the solution can fit in the kernel, how we develop it. And this takes a lot of time. Yeah. So at the beginning, you are required to create a downstream solution to start your development. And our goal is also to provide this as fast as possible with new silicon. And there's, I guess, no alternative to this. I don't see it. Yeah. But the point is that as long as the product is going and you have to, TI products have a very longevity, but yeah, we have products in the field which are ages, I don't know. And the important point is that you don't stop investing in the software. Yeah. So over years, you still have to invest in software to bring the missing features upstream. So maybe this is a jump to the panel. So what about those features who never get upstream?
Yeah, and I think Nihai, talk about that because you have a lot of experience there.
So personally, I tried upstreaming a dynamic DDR detection scheme, and that didn't go very well in U-boot. So there was a lot of back and forth, and not a lot of people agreed with it. So it ended up just being, internal. So I think reviewing, and this is maybe a personal challenge that I've always faced is with reviewing, specifically in U-boot. And maybe I also want to kind of segue and ask you guys, from all the components that we have, I've noticed that certain components don't get as much attention on the mailing list. Do you see that? And is there a reason why you feel like the bootloader is being overlooked at some point? Maybe this is going a little bit off direction
No,
from
it's still valid, right? It's how much
but this
interest
is
there's in the
something that I
community for it.
personally have felt. So, do you have any
Comment on that?
Yeah, I don't know specifically about the bootloader, but I would say it gets into kind of back to the basic question: how do you trust things, and why do you trust things? And I think the answer, one of the answers there is the more that the software is used by other people, the more you trust it, because you start to trust it. And so the more maybe niche the feature, the less people are using it, and then the less important it becomes, or the less it gets prioritized with upstream reviews, which is, it's kind of just limits of the community. There's not going to be involvement on every single topic.
And
so
generally, I guess the smaller, also, the more opinionated someone might be about it, they get a bigger voice because there's not that many people reviewing it at that point.
Yeah.
But
Yeah.
in general, I've seen the trend specifically for, I'm guessing everyone is using U-boot as the bootloader. So I don't know. I don't see many reviewers online. Yeah.
Well, it's like the art of getting things upstream is really what I said, an art, right? You need to build consensus, find the people who are interested in the same topic, not be alone in pushing your thing, but it requires time and effort. And so that's kind of going back to the question of like, how do you combine upstream and releasing a product on time, right? I'm going to say it's impossible. We are at the crossroad of exactly that, for being ourselves contributors to Upstream and also helping our customers ship products. So I think it's basically impossible, but at the same time, Upstream shouldn't be seen as like a black and white thing where on day one everything has to be upstream. It's more of a process where on the maybe not long run, but let's say midterm, you have to have insight that over the next couple updates of your product, you want to reduce your backlog of non-upstream things. So of course, if you start with some hardware or software solutions that are highly non-upstream, that path is like never ending. But if you start with a solution like a hardware solution, it's already mostly supported upstream, but there's a few things not upstream because upstreaming is a challenge and because the communities want to take the time to review, to find the right solutions for every problem. And that's totally fine. And that's why we love open source, I think. They just don't accept things because you're shipping a product next day. But you want to see that backlog of non-upstream code progressively reduce, I don't know, months after months, year after year, so that progressively as your product gets, let's say, older, and for you, the maintenance is more and more of a burden, but you still have to do it because of CRA. The cost of that maintenance also lowers down because you are, at the end of the day, upstream almost entirely or ideally entirely. So I think it's more of a process than a state at day one of shipping the product.
Yeah, and when we preach upstream first, that's what we mean, right? We don't actually mean like all the code is always upstream by default. It's we write all the code from day one with the intention of upstreaming as best as we can constantly, and we try to keep that backlog low.
Yeah, it might not be upstream at launch, but the goal is to get there for any product that's going to be on the market for a long time. You mentioned the burden of ongoing management. I think using an upstream kernel, if you look at like the percentage of CVEs that are discovered by the Sysbot, Syscaller infrastructure, like coverage guided kernel fuzzing with KSAN enabled, it's probably like half of the kernel CVs are literally found by that fuzzing infrastructure. And so if you're running a kernel that is too far off mainline, you're missing out on that. I guarantee you have more memory corruption, potentially exploitable memory corruption bugs that aren't getting looked at because there are fewer eyeballs. I mean, all bugs are shallow when there are enough CPUs churning away at fuzzing, I guess.
And I think that you'll find that everybody on this panel that has done any sort of work upstream has had the exact same problem as you, where getting attention on the what you're trying to improve and change has been a challenge. And if it's if it's not doesn't impact enough people, maybe, and you can get in with the maintainer and make sure that they can test it and it goes in nice and easy. I think when you talk about something like DDR, that probably has a big impact on a lot of people, and you're asking a lot of people to kind of go and test, and maybe that's a little bit harder. I know that we've been struggling with some of the things that we enable out of tree to we've got a patch that's we still apply to the kernels that's maybe 12 years old by Pentelis and Antonio to try to provide dynamic device tree overlays, right, to help people, because it allows them to do some on bench development that introduces a lot of security issues, right? But it's important, and we're still struggling to kind of move that conversation forward on something that in fact impacts a lot of different people. So if anything, don't feel alone. But the conferences like this and face-to-face discussions and getting to know some of the names behind the emails and being persistent and also enabling people to really bring it to their desks in their kind of workflow, right? Sometimes it's people get much more specialized all the time. And so trying to find ways to meet them at their workflow is like one of my personal challenges, right? Trying to find a way that somebody can test what I'm looking at very quickly and easily.
And you mentioned these U-boot features, but I would also add there's still other maybe larger gaps that people are more interested in. I mean, graphics is one of the common ones that people bring up, but on TI chips too, when there's all this multi-core stuff going on, all the remote proc and IPC type stuff that's going on, there's still issues there. There's power management things that are downstream and not upstream. So there's some pretty big gaps. But the good thing is that even like you at least tried to upstream something. So somebody that's really interested in that feature, they can take it and use it if they want to, even if it doesn't get upstream. A lot of other chip vendors are just not even doing that, right? So at least it's still the conversation in the open. We know this is out of tree, but at least we have it to share. That's already a huge advantage. Even when the gaps are still big, at least they're open and people that really need it can self-serve.
And the stuff that we pull down like and apply is stuff that went to the mailing list and just never got done. And just for convenience, we go and apply those to our kernel so people can play with it and hopefully contribute to the conversation.
I was going to say, at least it's out there. And this kind of also falls into the topic of, right, we kind of talked about testing, right? So you have the problem of, okay, a vendor breaks things between releases, but we also have the other problem around where because everyone's contributing upstream, sometimes an upstream contribution breaks stuff on a vendor device. So we see that a lot where, something like MMC or display might break because another vendor pushed a change for their own platform. And in those cases, what do you do, right? Does the kernel get sufficient testing upstream on all the devices that could possibly run on that code that, it's sufficient testing? And I was kind of going to show what we do at TI as far as the CI/CD snapshots that we publish. And I can let Vishnu talk more about that. But basically, we have kernel CI running and other CI/CD snapshots for all of the current devices and EVMs. And you can go on ti.com and get these live results. You can actually click on the link to show you. If PowerPoint lets me, let's see. There we go. So we can look, for example, we have AM628 here, and we can see the latest testing results, what's passing, what's failing, live in the board farm. So these are actual EVMs being tested at TI. You can see what images they're being tested against, what the build instructions are, so you can try to reproduce it, and you can see all the tests. You can click on a test and actually see which EVM did what test, why it failed. You can get the full log just publicly. And it's not perfect. It's still getting worked on. There should always be more testing, more hardware testing. It's definitely not complete, but I think the way that industry in general needs to move, right, is to actually publish their testing results, the testing methodology, and then not just for the vendor kernel, but also do the same kind of regression testing for upstream. And personally, I think that even, as just a regular user, you should be able to reproduce the same testing and, publish your tests and say, hey, I think I found a bug. Here's my results, matches your testing. I guess, do you want to comment more on it? Yep.
Yeah, right. So at TI, basically, we had this CI/CD where any patch you basically take backport or upstream, right, goes to these devices, branches, and basically your CI/CD gets triggered, right, and where it builds that kernel, deploy it to device, right. Basically, we call it core SDK, which and we deploy the actual device. It gets flashed over there. It runs. We had like multiple test cases for each device specific as well as the common cases as well. So each one gets run over there, and then basically you get the complete result. And it also, you can see whatever as he was mentioning, right, when it fails, right? So you have the complete information of loss, right, where it fails, how it fails, okay. If there is a problem, so developers can go quickly fix it and push it back. So this is basically a continuous, it's not like stopped on a certain version or branch, right? It is a continuous process, keep on happening. So everything you do, it will get tested by this complete test framework, right? Yeah. So that way we can say, okay, whatever the code we are pushing or open upstreaming, this gets tested over here, right?
And this is part of how you get the confidence that Jason was talking about, right? It's like, how do you trust the software that's running?
Right.
It's,
Yeah, so any customer, any user, they can just go and see what things we are running on each of their SOC version and what is passing, what is failing. So they have the clear picture of what is happening over there, right? And apart from that, right, even the complete SDK perspective, let's talk about the Yocto, right? Yocto or Buildroot or Debian, right? So even we do SDK level testing for these SOC as well. So we have basically the robot-based framework, which has the SDK integration level testing. Let's say you have use case of the running your out of box some applications or some GStreamer related or multimedia related, right? So we have certain test cases. We have automated that as well using the robot framework which we have. And those reports also, you go to any SDK page, you will be able to see some of the reports over there as well, right? So that way it means you can say that, okay, whatever we are doing, it's well tested before it goes out.
Yeah, and I would just add, I'm with my kernel CI hat on, which is focused on upstream testing. TI actually recently joined the kernel CI project, so I'm actually looking forward to seeing. So this stuff right now is doing kind of TI downstream kernel stuff, and they've just started trying to do the similar type of tests with upstream kernels, and that should be really promising, because then as a consumer or somebody that wants to make a product, you can look and see if the same types of tests are running just as well upstream as a downstream. You might pick a newer kernel and not pick one of these releases. So it gives you as a consumer like the trust. If you're trusting which tests are running or what are the tests that I really care about, if it's just as good upstream, you might actually pick a different kernel. And so I'm looking forward to seeing these similar kind of results on upstream kernels as well as downstream kernels. And then it'll also start to show where the gaps are. We know the things that are tested downstream and not upstream because the features don't exist yet upstream. It'll just be another way of showcasing that. Yep.
I'll talk about something else where people are using not upstream kernels, and that's a lot in education, where people get tied. We still had people building 2638 on AM3, not that long ago, and to the point where we had to apply patches as we, end of life parts on BeagleBone Black. We had to go back and push MMC patches back to 2638, But it's crazy sometimes if you have a textbook or you have some other like really detailed things that dive into the kernel, it's very hard to stay up to date. But I think that it's kind of a counterpoint that I want to ultimately make with that is that the closer and closer things are to upstream, the more likely they're going to change, and the more that we can choose an education platform that teaches people something that's actually directly using mainline, the more likely that's going to stay valid for a much longer period of time.
To go back to the testing aspects, I think it is obviously really great to automate testing of both vendor and upstream kernels, but one should not miss the fact that it's extremely difficult to do a full coverage testing of something like an SoC hardware support. There's like literally millions of features in an SoC. And I mean, the number of display interfaces, audio interface, number of type of cases in which they can be used is enormous. So this can only ever test like a good, useful, but only a subset of all the features. And this is really a challenge, I think, for testing in general for the kernel project, because it's really affected by that huge variety of features. And I don't really have a solution for that. I'm not sure there is a solution.
I think it's more just a general call to the community, right? Of like, just the Linux community and everyone else in open source, right? It's just working on these open test frameworks, extending them and adding as many possible use cases, lowering the cost of hardware, lowering the cost of software, basically lowering the barrier of entry to make testing common across the board for every vendor, right? And just making testing itself open.
Yeah, I mean, you can test all you want. I mean, that you can invest in tests as much as you want, and you will always find errors and so, yeah.
Yep.
So I guess what everyone is doing is taking his all at the supply chain and testing specifically for those errors or mistakes he's responsible for, yeah.
Mm.
And for example, we also have running CI tests like you guys are doing. We focus on our systems, what they are using, and do actual interface testing. So with the complete hardware, yeah, and so this focus on different errors, and with that you find different errors, but that's our part. So, and we are now also starting on some products to use directly vanilla kernels in those loops to also get some of the diffs, yeah. Mm-hmm. And so this is a point where I think an open infrastructure from you guys is important, so we can discuss those things. Yeah, what we find, we can give back to you. We see what you're testing, and so if everyone is open with those infos, then the supply chain is much quicker in finding the real issue or whatever. Yeah.
Yeah, it's essentially how we add value at every step, right? That's how you're adding value, testing on your own hardware and showing your customer that way and feeding it back in.
I have a question. When you go into production, when you do testing, do you cut down and have a minimal configuration that you're testing? Because if that's the case, this is still helping because you're testing out the bigger picture and then you're just taking a subset and doing extensive testing on that. So
We do a couple of different things at Toradex. So we have a couple of BSP reference images. There's a minimal reference image and a multimedia reference image that are built in nightlies, and whenever there's a BSP release, are extensively tested with. We use Lava as the test framework, and so we get hardware testing. We also have Horizon OS, which is a more complete production-ready OS, Yocto-based OS distribution, and for that we do even more extensive testing because it's just bigger, and we are still stuck doing some significant amount of manual testing for things like a lot of display-related stuff, verifying boot splash screens and things for all the different display interfaces we have. So yeah, we have different targets that we test for that are appropriate for different customer segments, right? People who are doing a heavily customized build probably aren't going to get that much use out of our Horizon OS tests because they just have different configurations. Hopefully there's some overlap. But then we also have that small core set that builds an image that's roughly core image minimal in Pokey and runs tests for basic hardware enablement features. You can't serve everything with one set of tests.
Okay. Yeah, to your question, so what is a little specialty at Firetech? We have at our headquarters the development and production at the same building and company. And so our hardware developers develop the test for production, and at the same time we use the same test setup for CI testing our software. Yeah, so we focus on really the hardware testing, so to have error-free production, but use the same setup for the software. So for the development boards, we have a lot of hardware coverage, to say, from all the interfaces we build on the development boards. Yeah.
I think that's something that in software circles gets potentially missed a lot, but board-to-board variability can actually impact a lot of your testing. Well, you have, maybe in that list you'll have 2 boards if they were poorly produced, right? Where they're not golden samples and all of a sudden they're going to have these random failures, right? And you're saying, okay, what's wrong with my software? Where it might not be your software, it might be trace lengths on your PCB for a high-speed signal or something like that. Or you have a buck regulator that's a little noisy just because that's how that PCB house made it. So part of it is also hardware testing, hardware production quality, and having reputable sourcing.
And kind of back to the CRA, one thing that's a little bit new here is we've been talking about testing for functionality and for hardware bugs and for like traditional software bugs. But back to the CRA, there's also CVE type of things that and it's also, we need to get tests that prove that CVEs are fixed and the response times are appropriate. Like not many people are doing that type of testing, at least publicly. I know people are doing that testing, but that's another area that like is completely different from functional testing. It's actually security testing or CVE proof, and those kind of things are going to be coming as well and needed because of the CRA. And yeah, I don't think those are in that test suite yet. But.
Not yet, but yeah.
I'm curious, what are you? Because of course there's the whole CV check subsystem in Yocto, and generally when nowadays when people backport patches, they also include a CV status, so that in the CV check you get in your output SBOM or VEX documents, you get that traceability to the patch that was applied. Are you thinking of additionally actually testing the exploitability, the effectiveness of that applied patch?
to me, it's like one more level of trust, right? Because in the Yocto, you're just claiming that somebody put the right tag in their recipe, right? So it's you're trusting the upstream that fixed the patch. I think another level might be actually for critical things, proving that things are actually fixed or that the holes are gone. But even what you're talking about, the SBOM is one thing, but showing that in test suites and software releases that there's some level of trust, or all this list of CVEs are fixed. I mean, that's just becoming increasingly required, right?
We've started doing that for high criticality ones. I mean the pseudo bug from this year, we added to our lava tests recently, I believe, because that's just a nasty one. Hopefully it doesn't affect a lot of embedded devices, but if it affects you, oof, it's pretty brutal.
So,
Let's say the CV patches, whatever is getting applied, right? So when you are going to test, right? So who's basically giving you the test? What to be tested over there? Is it the whoever is fixing that bug? It's already part of that, or who's going to write the test cases for that, right? So that's my point here, means who's going to write that? That's something which...
That's a big question.
Yeah, that's
Right.
definitely not being done.
Right, because
Internally,
someone else has fixed that issue and pushed the patch, but again, he may not be pushing that test case, how to test that, right? And if that is not available, then as us, right, we can't do much more on that, right?
it's an evolving kind of collaboration thing, right? Where we have to work basically, I think, to kind of define those test cases and work with both, amongst ourselves and customers to kind of, and regulators to align along it. Just in the interest of time, I think we have to kind of.
Can I make one last poke at the panel?
Poke at it.
So I have a certain perception of Yocto, which I know a lot of people here use to build production ready software with. It's because it's a fantastic tool for creating reproducible builds. But we're talking about Upstream, and in a lot of respects, I kind of see Yocto as a place for bug fixes to go to die, right? Because it's a way of ultimately not fixing upstream, right? It directly addresses the inability for folks to go and actually fix bugs upstream, right? Including just something simple as like supporting cross compilation, right? It kind of lives in an entire space of not fixing things upstream. So just kind of, does anybody have an opinion about, is Yocto the place where bug fixes go to die?
Not more than in any other distribution, right? So you're pointing Yocto specifically, but Debian has stacks of patches. All distros do that, and they have more or less of a policy to aggressively push things upstream. So I put my Beetroot add-on. We require having an upstream tag on every patch that we add, so they must be submitted. And I think Yocto has been less historically not as strong on that, but they've also raised the bar on that as well. I think it makes sense, of course, that this should be a requirement, but I don't think Yocto really stands out. Debian has tons of really crappy things that have never been sent. So I know you use Debian, so that's why I'm using that one example in particular. But they've not been extremely good either at pushing things upstream.
Well, I think
I was going to say the upstream status field is present in high quality BSP. If you saw somebody else's talk earlier today, Francisco sitting right there, has hundreds of upstream kernel patches and probably hundreds more in U-boot. People do upstream things, but Yocto patches need to get in the layers to fix issues in production, because that's how you fix it fast. You need something working. You can't wait for acceptance. I mean, if you've got a better idea on how to make it work. Yocto is one of those things, democracy is the worst system of government except for all the other ones. Maybe Yocto is just the worst way to do an embedded Linux distribution except for all of the other ones.
Yeah, I think the point is not to point finger at like, oh, this distribution or that. It's more to say, we're all trying to converge towards a good middle ground where, everyone has their idea of how it should work. And, maybe it's Debian, maybe it's Yocto, how they're doing it, or maybe some other, magic layer that we'll eventually get to in 5 years where we completely disagree again. But yeah, just to kind of focus us on time, because I think we're getting towards the end, just a quick question is, why do you guys bother building on TI at all? Oh, no, wait, I mean, yeah, no, it's good that...
I mean, I'm holding a mic, so I might as well start. Excellent. We recently evaluated a bunch of chip suppliers for some new modules, and a module based on the AM69 went out in that case, and there were a lot of considerations, but certainly high quality upstream Linux support was a major one that matters for our customers, for our industry. Also, that's a nice SoC. I'm using it myself at home.
It's fun.
Well, pain points, I guess, what remains not really publicly available documented. So I'm going to point GPU graphics and some of the security features, maybe, that tend to be sometimes,
Yep.
not so well documented / supported.
Yeah, and the broad features from the SoCs are well documented. I mean, we were in discussion with all the SoC vendors, and I mean, some people you talk to and you know they get a very complex SoC and they get a data sheet of 120 pages, and you already know, okay.
You mean you don't need more?
And then you get a TI data sheet, and that's at least 10,000 of pages. Yeah,
You don't have to read all of
Your
it, but
PDF
you can if
reader
you want.
struggles reading the data sheet.
need to patch your PDF reader. Yeah, and adding to that, the communication publicly available in the forum, and so it's very important to get the stuff actually running.
I would also echo some of the security features could be a little bit more open or well documented, but it could be worse. I won't name and shame anybody here, but I've dealt with SoCs where you don't get any like OTP flashing tool or reference implementation. You get a data sheet that tells you where you've got to put some sig bits. So
Or a bank account where you can deposit some funds.
or that.
I'm very happy with the AM625. We're finally getting an open source 3D graphic support and user space. So that's very appreciated. And I would certainly echo all the other comments about why to choose TI, but I would also highlight distribution availability and longevity. It's kind of pointless to do something you'd call open hardware with chips that people can't actually buy themselves. So as a maker of open source hardware, choosing a TI device that people can buy in distribution in quantity 1 and still going to be available for over 10 years from now is a very big deal, especially if anybody's going to create some sort of educational materials or teach people about how to do things. They're going to need to continue to have that hardware available for a long time.
Or even to do products.
Absolutely, to do product.
All right. So with that, I think we can open up some questions. If anybody in the audience has any questions, and otherwise, again, thank you for your time. Thank you for coming, and hopefully we didn't bore you to death, and you've learned something interesting today. And feel free to toss any kind of questions or complaints, good ideas, anything our way. All right. All right.
Maybe this is one more for the TI product people. So regarding Jason's comment that he wants to trust the hardware that people have in their hands and make sure that they are authentic, even without secure boot, that would be interesting if TI had in their stock something like NXP's manufacturing protection, which is basically attestation of the ROM code or of the bootloader which is booted from the ROM code. That would make building things on top of that much easier. Just a comment.
Could you expand a little bit more about what they do?
Okay, so basically they have a secret key in this SoC which is only readable by the ROM code, and you can, after the bootloader is authenticated, it generates an attestation that this is the hash of the public key that the bootloader was signed with from a key that is only known to NXP. So if I trust NXP,
We have the
NXP
exact same
SoC?
functionality of the HSFS devices. So all the modern TI SoCs are on HSFS. So by default, even if with the unburned keys, they do have a TI public key that was burned against them.
And can I get an attestation from that?
I believe so.
Then please
Yes,
document
yeah.
it.
Yeah. There you go. Yeah. No. Fair enough. Fair enough. Yeah. Yeah.
I think it is.
Just from a Beagle product perspective, so the Beagle Play devices shipping still are what's called general purpose or GP. They use TI uses the term GP devices, which don't have the high security firmware in it, which means you can boot entirely without the TI firmware blob or the TI functional safety TIFS blob running on the R5 that's used for boot. But the Pocket Beagle 2, which I haven't done a whole lot to promote about yet because we're still trying to do a lot of upstream work, but it's going very nicely so far. But the Pocket Beagle 2 does ship with the HSFS devices, right? So and a fuse, not a fuse, a jumper for being able to program the fuses on there if you did decide to lock it down to your own.
So I can burn fuses on the Pocket Beagle too.
Yes.
Correct. Yeah.
Nice.
Okay. Any other questions? Yep.
Thanks. So if I go to TI's Git, I get like a vendor kernel, right? 6.12 with I couldn't count them because it didn't clone. There's a few patches on it. So as a user of a TI chip, what's my path towards an upstream kernel?
So you can build the TI, if you guys want to answer, but you can build the TI kernel, or you can go ahead and build the upstream kernel for most devices. Like AM65 is fully upstream, so you could just pull Torvalds Linux and then build the same way, and it works. I use the Armbian build system a lot. You could always just switch over, literally switch your source for the Git tree from TI to Torvalds, and then it will build the exact same way. Just, again, some of the TI enabled only features might not work the same, but you'll have a booting board same way.
You can also look up Thanks. Okay, or you can go to the vendors and look at their BSP. Yeah, for example, the 6.4, AM6.4 is completely mainline supported from Firetech, for example, or...
Yeah, similarly, you can keep up with the status of mainlining. We have an AM62 and an AM69 that are still based on the TI kernel for what we recommend for hardware enablement, but it gets there eventually.
Yeah, on my personal Beagle Play that I use, I just built the mainline kernel out of tree, just out of Git clone LTS. I built LTS, not the current mainline, but and just use the device trees that are there, just boots. It's fine.
One thing that could be useful, though, is I'm not sure that's available from TI, but it would be like a matrix that clearly shows the state of the support between vendor kernel and upstream to precisely answer that kind of questions like, hey, this feature, like, LVDS support is in mainline since, 6.11. This other feature is submitted. Here is the patch series. That kind of matrix would really help understand what's the difference between the level of support in mainline, the level of support in vendor, and kind of also show, as I was mentioning earlier, upstreaming is a process where at what stage you are in the process for that particular other feature. Maybe it's not yet in mainline, but it's already posted, it's in, V12 or whatever. With the link to the patch series, that would definitely help answer that kind of question.
And I am actually taking notes from what you said.
Yeah, getting it up on a wiki or something in the past. I know TI has their testing report that they put out, but I think bringing something to a wiki or other places. Certainly people are welcome to post on the BeagleBoard forums, and I think you're always welcome to send messages to the kernel mailing lists, the appropriate kernel mailing lists if you've done any sort of testing. If you want to speed up testing, you don't want to build the kernel, we also do make Debian packages of the mainline kernel available in the Beagle Debian package feeds.
Other questions? Okay. Well, and thank you guys for coming. Big surprise, the two people that did ask questions, you get a free Beagle Y. If somebody has a third question, go for it.
Thank you.